In the realm of robotics, there exists a set of fundamental principles known as the three rules of robotics. These rules, first introduced by science fiction writer Isaac Asimov in his stories, have since become a cornerstone in the development and ethical considerations of artificial intelligence and robotics. The three rules of robotics serve as a guiding framework for ensuring the safe and ethical interaction between robots and humans, shaping the way we design, program, and interact with these intelligent machines. The three rules of robotics are as follows. 1. A robot may not injure a human being or, through inaction, allow a human being to come to harm. 2. A robot must obey the orders given it by human beings except where such orders would conflict with the first law. 3. A robot must protect its own existence as long as such protection does not conflict with the first or second law. These rules may seem simple at first glance, but their implications are profound. By prioritizing the safety and well-being of humans above all else, the three rules of robotics set a standard for ethical behavior in the field of robotics. They ensure that robots are designed and programmed with a built-in moral compass, preventing them from causing harm to humans intentionally or inadvertently. The impact of these rules on the development and interaction of robots with humans cannot be overstated. By adhering to these principles, engineers and programmers are compelled to prioritize safety and ethical considerations in the design and implementation of robotic systems. This not only fosters trust between humans and robots but also mitigates the potential risks associated with the increasing integration of AI and robotics into our daily lives. In today's technological landscape, where advancements in artificial intelligence and robotics are rapidly transforming various industries, the relevance of the three rules of robotics is more critical than ever. As robots become more autonomous and capable of making decisions independently, it is essential to ensure that they operate within ethical boundaries and do not pose a threat to human safety and well-being. In conclusion, the three rules of robotics serve as a foundational framework for the ethical development and interaction of robots with humans. By upholding these principles, we can harness the potential of AI and robotics to improve our lives while ensuring that they remain safe, reliable, and trustworthy companions in our increasingly interconnected world. The first law of robotics, as articulated by Isaac Asimov, states that a robot may not injure a human being or, through inaction, allow a human being to come to harm. This foundational principle underscores the paramount importance of human safety and well-being in the design and operation of robots. Originating from Asimov's science fiction stories, the first law serves as a moral imperative that guides the behavior and decision-making of intelligent machines. Examples abound of how the first law influences the actions of robots in various scenarios. In industrial settings, robotic arms equipped with sensors are programmed to detect and avoid collisions with human workers, ensuring a safe working environment. Autonomous vehicles are designed to prioritize the safety of passengers and pedestrians, employing advanced algorithms to make split-second decisions that minimize the risk of accidents. Even in healthcare, robotic surgical systems are engineered to enhance the precision and safety of medical procedures, reducing the likelihood of human error and improving patient outcomes. The implications of the first law extend beyond the realm of robotics and AI, prompting us to reflect on the ethical considerations associated with granting machines the power to make life and death decisions. As robots become increasingly autonomous and capable of independent action, questions arise about accountability, liability, and the potential consequences of their actions. How do we ensure that robots always prioritize human safety without sacrificing efficiency or effectiveness? What safeguards can be put in place to prevent unintended harm or misuse of robotic technology? By exploring the first law of robotics in detail, we are confronted with complex ethical dilemmas that challenge our understanding of the relationship between humans and machines. As we entrust robots with greater autonomy and decision-making capabilities, we must grapple with the implications of granting them the power to determine the course of action in critical situations. How do we reconcile the need for innovation and progress with the imperative to protect human life and dignity? In conclusion, the first law of robotics serves as a moral compass that guides the behavior and decision-making of robots, emphasizing the primacy of human safety and well-being. By delving into the implications of this foundational principle, we are prompted to consider the ethical dimensions of AI and robotics and the responsibilities that come with creating intelligent machines that interact with humans. The second law of robotics, as defined by Isaac Asimov, states that a robot must obey the orders given to it by human beings except where such orders would conflict with the first law. This principle highlights the importance of human authority and control over robotic systems while also acknowledging the need for robots to act autonomously within ethical boundaries. The second law plays a crucial role in balancing robot autonomy with human safety and ensuring that robots operate in alignment with ethical guidelines. The purpose of the second law is to establish a framework for human-robot interaction that prioritizes human oversight and decision-making. By requiring robots to follow commands from humans, this rule reinforces the idea that humans are ultimately responsible for the actions and behavior of robots. At the same time, the second law allows robots to exercise autonomy and independence in carrying out tasks, provided that they do not violate the first law by endangering human life or well-being. In practice, the second law guides robot behavior in a variety of scenarios where human input and direction are essential. For example, in collaborative robotics applications, robots work alongside human workers in manufacturing environments, following instructions and cues from their human counterparts to perform complex tasks efficiently and safely. In domestic settings, robotic assistants are programmed to respond to verbal commands and gestures from users, enhancing convenience and accessibility in daily tasks. However, implementing the second law in real-world robotics presents challenges that require careful consideration. Ensuring that robots accurately interpret and execute human commands without misinterpretation or error is a complex task that involves advanced sensor technology, natural language processing, and machine learning algorithms. Additionally, balancing the autonomy of robots with the need for human oversight raises questions about accountability, transparency, and the potential for conflicts between human directives and ethical imperatives. Viewers are encouraged to reflect on the complexities of integrating the second law of robotics into the design and operation of robotic systems. How can we empower robots to act autonomously while maintaining human control and supervision? What mechanisms can be put in place to prevent misunderstandings or conflicts between human commands and ethical constraints? By exploring these challenges, we gain insight into the intricate dynamics of human-robot collaboration, and the ethical considerations that shape the future of robotics. The third law of robotics, as formulated by Isaac Asimov, states that a robot must protect its own existence as long as such protection does not conflict with the first or second law. This principle underscores the importance of self-preservation for robots while also emphasizing the need to balance this instinct with the safety and well-being of humans. The third law plays a crucial role in ensuring that robots are equipped to make decisions that prioritize their own survival without compromising the ethical principles outlined in the first and second laws. In robot programming, the third law holds significant importance as it influences the decision-making processes of intelligent machines. By instilling a sense of self-preservation in robots, engineers and programmers aim to create systems that can assess risks, avoid potential dangers, and take proactive measures to ensure their continued operation. This self-protective instinct is essential for enhancing the reliability and longevity of robotic systems in various applications. Examples of how the third law safeguards both robots and humans can be seen in scenarios where robots are deployed in hazardous environments or high-risk situations. For instance, in search and rescue missions, autonomous drones and robotic vehicles are programmed to navigate through dangerous terrain, assess risks, and prioritize their own safety while carrying out their mission to locate and assist survivors. Similarly, in industrial settings, robotic systems equipped with self-monitoring capabilities can detect malfunctions or anomalies and take corrective actions to prevent accidents or damage. Viewers are encouraged to contemplate the implications of the third law on the future of robotics and artificial intelligence. As robots become more autonomous and capable of making decisions independently, the ability to protect their own existence raises ethical questions about the boundaries of self-preservation and the potential conflicts that may arise with human interests. How do we ensure that robots prioritize their own survival without endangering human lives or violating ethical principles? By exploring the complexities of the third law of robotics, we gain insight into the intricate interplay between self-preservation, human safety, and ethical considerations in the design and operation of robotic systems. As we continue to advance the capabilities of AI and robotics, it is essential to strike a balance between empowering robots to protect themselves and ensuring that their actions align with the fundamental principles of safety, ethics, and human well-being. In conclusion, the three rules of robotics, comprising the first law, second law, and third law, serve as a foundational framework for the ethical development and interaction of robots with humans. Each rule plays a crucial role in shaping the behavior, decision-making, and ethical considerations of intelligent machines, ensuring that they prioritize human safety, obey human commands, and protect their own existence within ethical boundaries. The first law of robotics emphasizes the paramount importance of human safety and well-being, guiding robots to avoid causing harm to humans or allowing harm to come to them. The second law underscores the need for human oversight and control over robotic systems while granting robots autonomy to carry out tasks within ethical constraints. The third law instills a sense of self-preservation in robots, enabling them to protect their own existence while prioritizing the safety of humans. Collectively, these rules have a profound impact on the development and interaction of robots with humans, fostering trust, reliability, and ethical behavior in the field of robotics. By upholding the three rules of robotics, engineers, programmers, and researchers can ensure that robots operate in a manner that aligns with ethical principles and safeguards human interests. We invite you to like and subscribe to our channel for more content on robotics, technology, and artificial intelligence. Stay updated on the latest advancements, ethical dilemmas, and future implications of AI and robotics in our rapidly evolving world. Your support helps us continue to explore and share insights on cutting-edge technologies that shape our future. We also encourage you to share your thoughts on the three rules of robotics in the comments section below. How do you perceive the significance of these rules in the context of AI and robotics? What ethical considerations do you believe are essential in the development and deployment of intelligent machines? Your perspectives and insights contribute to a deeper understanding of the complex dynamics between humans and robots in our increasingly interconnected society. Thank you for joining us on this exploration of the three rules of robotics. Together, let's continue to delve into the fascinating world of robotics and technology, shaping a future where innovation and ethics go hand in hand.